Hi everyone, welcome back to my episode 2 video on trigonometry. We looked at we looked at the fundamentals of trigonometry, or the basics of trigonometry, by understanding the three main trigonometrical ratios. And we said that the three trigonometrical ratios, we looked at the SOHCAHTOA concept, okay? SOHCAHTOA concept, where we said that SOHCAHTOA is the one that consists of the three main trigonometrical ratios. We had the sine, the cosine, and the tangent. Now, I hope you understood. If there are any queries, I hope you leave your questions in the comments for that particular video so that I can attend to the questions. Otherwise, today I wanted to progress. I wanted to look at special angles. Probably I would say that special angles are very important because mostly in paper 1, these are the angles they like bringing, because these are certain angles that you can actually deal with without a need or aid of a calculator. So that being said, we have the following special angles. We have 0 degrees, we have 30 degrees, 45 degrees, 60 degrees, and 90 degrees. These are the special angles you need to know. So what I'm going to do is, I'm going to show you, today I'm going to start with 45 degrees. I'll show you how to get the 45 degrees applying the SOHCAHTOA, okay? Then after that, I hope in the second episode of special angles, I'll look at 30 and 60 degrees. I'll marry these together. Then I'll also get, in the third or fourth, I'll get 0 degree and 90 degrees. Okay, so with the 45 degrees, 30 and 60 degrees, I want to show you using diagrams. Then probably maybe with the 0 and 90 degrees, I'll just illustrate using the finger concept. But if you would want me to also show you the finger concept on 45 degrees and 30 and 60 degrees, you just have to leave the comment in the comments, mention that you also want to know how to use the finger concept on these three special angles. Okay. Otherwise, I will leave the formula that you can use with your fingers so that you can try finding these angles with the aid of your hand. Okay, I'll progress with 45 degree angle. So let me just rub that, just create some space. I'll have 45 degree angle, okay, 45 degree angle. What I'm going to do is, I'm going to come up with a right angled triangle, okay, let me have that. I'm going to have, let me get that, okay, I hope you're able to see that, okay, so let me have that, okay. Now, this will have 1 unit, okay. Then this side also have 1 unit, okay. Now we know that this is a right angle triangle. It has a 90 degree, and the fact that the two sides have been given as 1 unit, meaning that this side and this side are of the same size, okay, which it tells us that this is a right angle triangle which happens to be an isosceles triangle. That simply means that this angle here and that angle here will be of the same side. In other words, the two base angles are equal, okay? That mentioned, I want you to look at the aspect that you have been provided with with two sides, okay? You have been provided with two sides. That simply means that you can actually apply the Pythagoras theorem to find the remaining side. Now before that, I want to remind you, in the previous video, we looked at these sides and we saw how we named the sides, okay? So we know that this side is exactly opposite to the 90-degree. We call this as hypotenuse. And we also mentioned that the adjacent side and the opposite side depends on the angle you've been given. Okay, I made that point clear. If you have forgotten, please just go and watch the previous video and you will see I explained about that. Okay, now that said, we can see that it is the hypotenuse side that we have not been given. So we can use the Pythagoras theorem to calculate for this side. Okay. Now let me call this side A. Okay. So what we are going to do is we're going to say A squared is equal to 1 squared plus 1 squared. Okay. Then I'm going to say, okay, A squared is equal to 1 squared is 1 plus 1 squared is 1. Okay. Hence, I'll say A squared is equal to 2. Okay. Now, the idea here is I want to get A. So, whatever is on the left side shouldn't be there because I only want to have A. So, how do I eliminate the square? I'll introduce the root. I'll introduce the square root. Okay, I'll introduce the square root. Now, whatever we do on the left side of the equation, we also do it on the right side of the equation. Hence, what we are going to have is the 2 will cancel with the square. So we'll get A is equal to the root of 2. So this side is the root of 2. Okay. That's how we get the hypotenuse if we were to use Pythagoras theorem, okay? And I suggested to use Pythagoras theorem because you can see that you have been given 2 sides. That becomes easier for you to use Pythagoras theorem. Now, let's forge ahead. We have the 90-degree here. What I want you to do is, I want us to find this angle here and that angle there, okay? We know that the 3 interior angles of a triangle adds up to 180. That we know. We also know that this right angle triangle happens to be an isosceles. So meaning that this angle here is the same with that angle there. They are of the same size. Okay. So let me just rub the working space here. Okay. So what I'm going to do is I want to extract these 2 angles, okay? And I know that this angle here is 90 degrees, okay? But how do I get these 2? And I know that these 2 angles are the same, okay? So what I'm going to do is, I'm going to say x degrees plus x degrees, this angle plus that angle, okay? Plus 90 degrees, it's supposed to give me what? 180 degrees. This is using the property which says the 3 interior angles of a triangle adds up to 180. So I'll have 2x plus 90 degrees is equal to 180 degrees. Okay, let me just pause a bit there. I'm stretching myself. Then I can see that 90 is that term with 180. So I'm going to have 2x is equal to the 90 has to cross, so you have 180 degrees, and we can see that the 90 is carrying a positive sign. So when it crosses on the other side of the equal sign here, meaning that the sign will be converted to a negative, so it will be negative 90 degrees. Hence, I'll say 2x is equal to, I can subtract 180 minus 90, which is going to give me 90 degrees. Then I can divide by 2. Remember, the idea is to find x. So the 2 and 2 will eliminate, and x is going to be what? 45. 2 can go into 90, 45. Okay? Now, 45 degrees is the angle, and I know that this angle and that angle are of the same size, so meaning that this angle is exactly 45 degrees, this angle is also 45 degrees. How can I prove this? Remember, the idea is, with the property that we've used here, the many three interior angles adds up to 180. So if I say 45 plus 45, that will give me 90. 90 plus 90 here is supposed to give me 180. Okay? Now I know I'm on the right path. You can also use another property. Okay? You can also use another property where you just say, you know that these two angles are of the same size because this triangle is an isosceles. So I can just say 90 divided by the two angles, which is going to give me what? 45 degrees. Then I have the two angles. Okay? So now we know that the angle is 45 degrees. That angle is also 45 degrees. Now allow me to just rub one side so that we only focus with one side. But it can work either way. If you want, you can try it on your own time. You can try using the other angle, but I will get this one, 45 degrees. Okay, now what I want you to do here is, we have a 45 degrees, which is our interest here, because we're looking at 45 degrees angle. Okay, 45 degree angle. So, looking at the diagram I have all the three sides given. I have 45 and all the three angles given, 45 degrees, 90 and that 45 degree there. So, I want you to apply the SOHCAHTOA on this particular triangle. So, we know that this is the angle given. Now that we have an angle given here, we know that this side will be what? Adjacent, right? We also know that this side is exactly opposite to our given angle. So this side is the opposite. And of course we know, we know that root of 2 is representing hypotenuse. Not so. Okay, now that has been said, we know how to now use the SOHCAHTOA, because you can't start using SOHCAHTOA minus knowing which one is opposite, which one is adjacent, which one is hypotenuse. You need to understand those three sides and how they operate or how they behave regarding to the angle that has been provided. Okay. Now in this case, this is adjacent, this is opposite. If the angle was here, it could have been vice versa. But the hypotenuse will maintain as hypotenuse in any situation. Okay. Now that has been said, I want us to apply, let's start with sine. So I'll get sine. To be sine, I'm getting the ratio. Sine theta is equal to the first letter opposite over h, which is hypotenuse. Okay. Now, this is my ratio for sine. So I'm going to say sine, the angle is 45 degrees. The angle is 45 degrees. Is equal to, opposite is 1, you can see that. Opposite is 1, so I'll put 1 over, okay. Then over what? Hypotenuse. Hypotenuse is the root of 2. So I'll write that, root of 2. So, this it tells us that when you have sine 45 degrees, it's equivalent to 1 over the root of 2. Okay? I'll say that again. Sine 45 is equivalent to 1 over the root of 2. So whenever you see an equation, sine 45, you can replace sine 45 with its equivalent, which is 1 over the root of 2. Okay, let me progress to cos. So cos theta is equal to adjacent over hypotenuse. Okay, so I can say that cos, okay, theta is 45 degrees is equal to adjacent is 1 unit, so it's 1 over hypotenuse, the root of 2. Okay, let me just progress from that far. So, or I can just end there because I thought you couldn't see, but I think it's fine there. I think my cameraman can agree with me. Is the 1/2, the one I can progress aside. Okay, let me just take it this far. And okay, so we have cos 45 degrees is going to be equal to 1 over the root of 2. Okay, thank you for that advice. So we can see that sine 45 degrees is equivalent to 1 over the root of 2, and cos 45 is also equivalent to 1 over the root of 2. There's one more ratio remaining. There's one more trigonometrical ratio remaining, which is the tangent. So allow me to just rub this, to just get some space. Just get some space for tangent. Okay, so tan theta is equal to opposite over adjacent, right? Getting from SOHCAHTOA. So I'm going to say tan, my theta is still 45 degrees, is equal to, now opposite is what? 1 over hypotenuse, adjacent is also 1. So meaning that tan 45 degrees is equal to 1. Okay. Which means that tan 45 degrees is equivalent to 1. So, I want to show you in summary, okay? I want to show you in summary. Let me just rub this. Just rub that. Okay, come back. That's one. Okay, so in summary, we are saying that on 45-degree angle, okay, sine 45 degrees is equivalent to what? 1 over the root of 2. Okay? Now, cos 45 degrees is also equivalent to 1 over the root of 2. Okay? And tan 45 degree is equivalent to 1. Okay? For today, that's all you have to understand about the 45-degree angle. In the next video, I'll talk about the 30 degrees and the 60-degree angle so that you can see how the same SOHCAHTOA can apply on those two angles. Then other time, I'll look at 0 and 90 degrees. Okay, so remember, what you have to do is, you are provided with the two sides. One unit this side and one unit that side. All you have to do is apply the Pythagoras theorem to get the hypotenuse side, which we did, and we got the root of 2. After that, find the two base angles. Find the two base angles, and we found was 45 degrees. That being that this right angle triangle happened to be an isosceles, meaning that the two base angles are 45 degrees. And that's what we are looking for, because we are focusing on 45-degree angle. And after we applied the SOHCAHTOA, we realized that sine 45 degree is equivalent to 1 over the root of 2. Cos 45 degree was also equivalent to 1 over the root of 2. And tan 45 degree was equivalent to 1. So, leave your comments or your questions in the comment section so that I can attend to the questions. And then before you forget, if you haven't subscribed to the channel, subscribe to the channel so that you support it. Okay, like the video, view it. Okay, and on the Facebook group, if you haven't joined, I would urge that you join. But of course, it's a closed group, so I'll ensure that you guys who are already in the group, please invite your friends. So far, the group is still small, but if you keep on inviting your friends, the group will grow bigger and you will support the group. All right, thank you guys. I hope you enjoyed the lesson.